Last time we talked about how we can change the pressures in the boiler and in the condenser to increase the efficiency. Is there any other way we can do to increase the efficiency? We have superheat and reheat. Okay, let's start from superheat. What is superheat? Let's explain that from this diagram. T versus S diagram again. Vapor dome first. Two constant pressure lines. And then we know usually number one, the outlet of the boiler is usually superheated. 122 go straight down. 223 go to the left, and number 3 is usually F point. 324 go straight up, isentropic compression, and then 421 to the right. Okay, so now is there anything we can do to increase the efficiency? Yes, we can heat up number one furthermore. So for example, if we heat up number one furthermore, what's going to happen? Number one will move, well, if you add more heat in the boiler, number one will move to the right because if you gain heat, you also gain entropy. Gaining entropy, that means your x coordinate becomes bigger. You must move to the right. So if I move number one to the right a little bit, and then I go straight down, number two will end up as G point. Or I can move number one further to the right, and then if I go down, number two will be superheated. Which one do you think is better out of the three? Of course, the further right you go, the better it is. Why? Because if you can move further to the right, what's going to happen to the area of the enclosure? The area of the enclosure will become bigger as the location of number one move to the right. So that's why the first method for us to increase the work or efficiency is superheat. The more superheated number one is, the better your system is. Okay, so the first thing is W cycle per unit mass must go up. Why? Because W cycle per unit mass is equal to the area of the enclosure. As number one moves to the right, the area of the enclosure becomes bigger, so you have more W cycle per unit mass. And number two, efficiency will also go up. Why? Because first of all, since everything is reversible, eta must be equal to eta max. And eta max has an equation, it's 1 minus Tc over Th. What is Th? Th is the temperature in the boiler, so that's 421. As you can see, if you move number one further to the right, what's going to happen? Number one is actually moving up. And what is my y coordinate? Y coordinate is temperature, so that means as the location of number one moves to the right, the temperature of number one also goes up. So the average temperature between 4 and 1, which is Th, also goes up. If Th goes up, the second term becomes smaller. 1 minus something smaller, efficiency will go up. And then the third thing we want to say about this superheat is point 2 can be a mixture, G point, or superheated. The location of point 2 depends on the specific problem you get, but number 2 can be either a mixture or G point or superheated. So that's the first way to increase the performance of this whole Rankine cycle by superheat. And the second way for us to increase the performance of the Rankine cycle is by reheat. So next, let's reintroduce reheat. How does reheat work? It's very similar to Rankine cycle. Let's sketch the diagram first. T versus S diagram. Vapor dome first. And let's sketch one constant pressure line. and sketch another one. Okay, so number one is the exit of the boiler. 1 to 2, still the steam turbine. 1 to 2, still a turbine, but this time it's the first turbine. We call it first stage turbine. After the steam goes through the first stage turbine, you send it to the boiler. So 2 to 3, along this constant pressure line, that's a new boiler. You send number 2 into a new boiler, and then it's going to gain heat at this constant pressure line, moving to the right. Because if you gain heat, you also gain entropy, and entropy is the x-coordinate. If the x-coordinate becomes bigger, you must move to the right. 2 to 3 is the boiler. And then 3 to 4. 3 to 4 is the second turbine. 3 to 4 is the second turbine. Sketch another constant pressure line for number 4. This is number 4. 3 to 4 is the second stage turbine. So you go straight down just like before because it is isentropic process. And then 4 to 5 will be the same as before. It's the condenser. How do we sketch 4 to 5? First of all, it is a constant pressure process. So 4 to 5 must be along this bottom constant pressure line. And then which direction? To the left or to the right? 4 to 5 is the condenser. That's where you lose heat. If you lose heat, you also lose entropy. So that means your x-coordinate becomes smaller. So you must move to the left. And then we always cool it down to F point. So number 5 is the F point. 4 to 5 condenser. And then 5 to 6 pump. Pump up the pressure before you send it back to the boiler. 5 to 6, you pump up to the highest pressure. So you go straight up to the highest pressure line. Okay, 5 to 6, go straight up. And then the last one, 6 to 1, same as before. 6 to 1 is along the top constant pressure line. That's the boiler again, where you gain heat. So now in a reheat cycle, you have two turbines actually. What's going to happen is, first of all, W cycle per unit mass will become bigger. Why? Because the area of the enclosure is becoming bigger, and the area of the enclosure is equal to W cycle per unit mass. And second thing is efficiency will go up, just like before, because you're increasing TH. And then part 3, the location of point 2 and point 4 can change. Point 2 and point 4 can be, just like before, mixture, G point, or superheated, depending on the properties you have. Okay, so we have two methods usually we can use to increase the performance of a Rankine cycle. The first one is superheat by moving the point number 1 to the right. The second thing we can do is to introduce two turbines in a cycle, and we call it reheat cycle.